Hi, my name is Timothy Hagge, and today I'm going to show you my photosynthesis lab. In this lab we will be using a manometer that I've designed to measure photosynthetic rate in plant leaves using a 200-watt light source. Photosynthetic rate in this lab is based on the amount of oxygen released by plant leaves during photosynthesis. So let's take a look at the materials that we have here. The light source we're using, we're just using a portable lamp with a 200-watt clear glass light bulb. Next you see what we call the heat sink, and the heat sink is a 4-liter aquarium. I just call it a banjo aquarium, and filled with water. And again, the water's here to absorb the heat energy coming off the light bulb. Next you see a test tube rack, of course, and a test tube. The test tube is a 25 by 150 millimeter glass test tube. Here you see the manometer, and I call this the Hagge Manometer, and it's one that I have designed and made. And this is a revision of the manometers that I have been using in the past that I've designed. The manometer is an acrylic plastic tube, and then I have taken transparency paper and photocopied graph paper onto the transparency paper. The graph paper then is attached to the U-tube manometer here. The graph is 5 millimeter increments here, the scale of the graph. Manometer fluid is just glycerol and water with green food coloring added. The carbon dioxide source, we're using sodium bicarbonate, and it's a 0.5% sodium bicarbonate solution. For our photosynthetic organism, I'm using plant leaves, and in the past I've always used the traditional LED or anacris aquarium plant, but lately we've been having some problems getting LED in, and even the quality of the LED hasn't been very good. And so I designed this or modified this just to use plant leaves, and it works very well. And I just using today some geranium plant leaves from the geranium plant I have in class, but I've used other fresh plant leaves, and I've also used lettuce leaves that I purchased at the store in the produce section. But today we're using geranium. Okay, so I guess we're kind of ready to set things up. So the first thing that we're going to do is add the manometer fluid to the manometer. And I'm going to use a plastic pipette here to add that because it fits the diameter of the tubing a little better. And I'm only going to add, a little over 1/2 milliliter or so of the manometer fluid. And I'm just going to remove it here. The trick is to try to get that to flow, not do that, the trick is to not do that, but you can handle that. Probably the best way is to just use the pipette and push air in and out there to get the manometer fluid to settle. And again, you need enough to kind of go around the band so that you're hitting the grids on the graph paper here. Okay. The next thing we're going to do will be to add our plant leaves, and I've already measured out 2 grams of my geranium leaves here. So add the plant leaves here quickly, and I've just tore these actually into smaller pieces. Here. Okay, so next we're going to add our sodium bicarbonate solution. And you want to add enough to to the tube to where you have about a centimeter or 2 centimeter airspace. You do not want the bottom of the rubber stopper on the manometer to contact the fluid, sodium bicarbonate. And as you see on the manometer, we also have a straight tube with a rubber hose attached to it. So when we start this, when we eventually start measuring the rate of photosynthesis, we're going to clamp this tube off, and then you'll have a sealed chamber. And so as oxygen is produced, the pressure of the gas or air inside here will increase, which will cause the manometer fluid to move up our scale here. All right, next thing I do is make sure that we are 20 centimeters away from the light source. And I want the center of the tube to be 20 centimeters away from the light source. So using my little ½ meter stick to measure that. And so now we're ready to turn on the light source. Now, I have it set at atmosphere, so with the straight tube unclamped, for a 5-minute equilibration period. And the 5-minute equilibration period is very important. You want to let the plant leaves sit for 5 minutes to gear up photosynthesis and get that rate going. And then also, the heat sink should be absorbing, is absorbing any heat off there, but you just want to make sure that in case there is some absorbing into the sodium bicarbonate, that you account for that. So again, we keep it open in atmosphere for 5 minutes here. So I better start my timer so we can measure that. 5 minutes set here. Start that. So we're going to let this go for 5 minutes, and then we'll come back and clamp off and start our first 10-minute run. We'll do a 10-minute run, and then we will release the, well, before we do our 10-minute run, I should mention this, we'll measure the level of the manometer fluid at the start. We'll then clamp off the straight tube to close our to produce our closed system. Then we will let photosynthesis occur for 10 minutes, and then we'll mark the level that the fluid rises in the manometer after 10 minutes. And then we'll release it back to atmospheric pressure. We'll do another 3 minutes at atmospheric pressure, and then we'll clamp it off and do a second 10-minute run. And we'll measure the level of the manometer fluid after the second 10 minutes. Then we'll release the tube back to atmosphere, and then do for 3 minutes, and then do a third 10-minute run. So a total of 3 10-minute runs, and we'll measure the fluid level after each run. The thing I should mention is that we do turn off the room lights once we start our run. And even during the 5-minute equilibration, we turn off the room lights so the room is dark. Okay, so the 5-minute equilibration is almost up here. We have about 10 seconds left to go. And so we're going to clamp off the straight tube. Okay, time's up, the dogs are barking. Okay, so now to close the system, we're going to clamp it off, but again, before we do that, I'm sure we get the starting level measured here. And looks like it's right here. So mark that with our transparency pin here. Now we're ready to clamp off our straight tube and start our first 10-minute run. Alright, so now we've created a closed chamber, and we're going to start our 10-minute run here. Now. Okay, so again, what we're going to do is let this run for 10 minutes, and after 10 minutes we will measure the level that the manometer fluid has risen, and then we'll mark that level, I'm sorry, then we'll measure it to determine exactly how many millimeters the fluid has moved. I'm going to zoom in here, take a look and follow the manometer here for a little while. Should be able to maybe see some oxygen bubbles present. Let's see if we can zoom in here a little bit. Maybe a few oxygen bubbles there. To our manometer here. So you can see that the manometer fluid is already rising. It's a great sign. Photosynthesis is occurring. Okay, so we're going to let that run for 10 minutes. So we have about 1.5 minutes left on our first 10-minute run, and as you can see, the fluid in the manometer is moving quite well. One thing I forgot to mention on the materials, the clamp, I am using a Hoffman tubing clamp there. So in this part of the photosynthesis lab that I do, what we'll end up doing is just getting a average rate of photosynthesis using white light. So we'll take the 3 runs, average those together, and divide that by the 10-minute time to get a photosynthesis rate per minute. The next thing that could be done then would be some extensions with this, where you could change the light intensity by moving the light source at different distances back away from the heat sink and measure the rate, and then compare that to the 20 centimeter rate. Another thing we've done, or what we do, is measure the rate using different wavelengths of light or different colors of light, and to do that we color the food, add food coloring to the heat sink, and then measure the rate of photosynthesis, and we do 3 runs with the different colors of light. Alright, looks like our 10-minute run is up. So what we'll do then is now measure the fluid level rise. There. So it's like, and then we'll let it back to atmosphere. So the fluid level will drop back down to its starting position. And then we will do 3 minutes back at atmosphere before we do our second 10-minute run. So the timer there. So we can measure that, and it looks like if we need to, we can always use a ruler, but here it looks like it's right on even increment markings. So we got 1, 2, 25 millimeters on the first run. And one of the back to the extensions of the lab. So again, with the different colors of light, we traditionally use blue, red, and green in color. Heat sinks have different setups, stations that use the one with blue light, one with green light, one with red light. And then we use handheld spectroscopes to measure the wavelengths of light that are coming through and what color bands do we see. Another extension I've done is just kind of after we do the part one is then just leave it open as to what the groups may want to do. So they have to pick a variable that might affect or influence the rate of photosynthesis, and leave that open to them with my OK to change or manipulate one variable. So some may decide to change the light intensity, some may decide to change the color of light, some may decide to change maybe the amount of plant leaves or the size of the plant leaves, or use different plant leaves, period. So make that a kind of open-ended, where they have to design the experiment and run it, repeat it, generate data, graph the data, and present the results. Okay, so we've got another minute before we start our second 10-minute run. One thing you could do, I have students do, is put a little number by their first run, so we know that that's run number 1. Another thing you could do is actually use a different color transparency marker for your second run, and then a different color transparency marker for your third run. Again, the numbering your runs works quite well. Okay, so we've got 5 seconds here. Okay, so now we're ready to start our second 10-minute run. So I'll just clamp off the tube. So now we sealed our chamber again, and we'll start our 10-minute run. Okay, so our time is up on our second 10-minute run. So if I can get the timer stopped, there we go. So let's measure our distance here. As you notice, it's just slightly under the first rate, which is kind of typical. I don't know if I have a good explanation for that, but it is typical. Okay, so then we let it back to atmosphere. And then we would do a second 3-minute equilibration or back at atmosphere, and then do a third 10-minute run. But we're going to stop here for now. After watching this video, if you are interested in finding out how you can obtain one of my manometers, just email me at tshagge@yahoo.com. That's tshagge@yahoo.com. Also, if you're interested in obtaining the lab handouts on the labs I do with photosynthesis, again, you can email me tshagge, tshagge @yahoo.com. And again, thanks for watching my video.